Hi everyone, welcome back to Class Go Education online YouTube learning channel. So this is Gaurav and today we will try to learn the step response of an RC circuit. So I will be explaining the fundamental and the concept basically with the help of one numerical. We will try to analyze what is the state variable, okay, what is the storing element, what is the order of the circuit, how we can determine the order of the circuit, okay, what is the voltage at a steady state, what is the initial voltage, and how we are able to calculate the current in the circuit. So on your screen there is one numerical whereby it is written the switch has been closed for a long time and is opened at time t equals to 0. Find the current, okay, find the current is over here, so this section, find the current and voltage, find the current and voltage for all time. For all time it means that we are talking when switch is closed for a long time and what will happen when switch will be opened. Okay, so what are the particular states of the current during these two durations. Now, so before I just get to the technicality or the solving methodology for this numerical, here first thing we have to understand what is the state variable. Okay, so over here there is only one storing element, that is capacitor. Okay, so capacitor basically stores electrostatic energy, that is half CV square. Okay, between the capacitor plates electric field would be there. It means over here capacitor voltage is the state variable. Capacitor voltage is the state variable. So one storing element and one state variable over here is capacitor voltage. So whatever the transient and steady state response we will be discussing, that too will with respect to the capacitor voltage. So in this circuit, if someone asks you what is the state variable, so state variable is capacitor voltage. Number of state variable only one, that is capacitor voltage. Okay, the derivative of that capacitor voltage. Third thing one can ask, what is the order of this particular circuit? So order of the circuit will be determined by the number of storing elements. So in this particular circuit we are having only one storing element, so the order of the circuit is first order. If there are two capacitors, one inductor, then probably the ordinary differential equation would be of third order. Number of storing elements will certainly let you know about the number of state variables, and that too equivalent to the order of the system. So this is the basic concept. So here I have considered two cases, when time t less than 0 when time t is greater than 0. So once we talk about for time t less than 0, it means switch is closed for a long time, capacitor has already reached to steady state and it will behave as a open circuit. Okay, and the unit step signal at time t less than 0, it will behave as a short circuit. We will be seeing the property of unit step signal later on, but right now you have to understand that at time t less than 0, unit step signal is deactivated. Okay, and for time t greater than 0, switch will be opened and unit step signal will come into the picture. So the reduced circuit for these two cases are as below. Now, so the for time t less than 0, so for time t less than 0, the circuit would be like this. Okay, for time t less than 0, circuit would be like this. Here you just see unit step signal is not there. Okay, it is behaving as a short circuited. It is behaving as short circuited, and capacitor reaches to steady state, that is why it is behaving as a open circuit. Now in another case whereby when we talk about time t greater than 0 and switch is opened now, Now when switch is opened at time t greater than 0, what will happen? You just see that unit step signal will come into picture, and there is another voltage source that was 10 volt that is disconnected. Okay, so the overall reduced circuit is over here. You can just pause down the video, try to make the initial circuit and try to analyze these A and B sections with that initial circuit. Now further moving ahead, we will try to analyze how this numerical can be solved. So before solving this numerical, we have to understand the concept of state variable. So you know that when we talk about a storing element like capacitor, whereby state variable is capacitor voltage, it means the complete response of capacitor voltage we have to study. So once you should know this thing, that complete response consists of two part. Okay, first is transient response and another is steady state response. Okay, so circuit will be having a steady state response and transient response. So here is the voltage across the capacitor. Here is the expression for the voltage across the capacitor. So in this expression, V infinity, this particular value will let you know about the steady state. This will let you know about the steady state. Okay, and likewise this particular value over here, this part will behave as a transient section. How you can say this thing is a, this particular expression is a transient? Because you just see over here, exponential term is there and tau is there, time constant is there. So in this expression you are having a steady state response and transient response. Okay, so simple thing over here that you have to calculate overall three values. First is you have to calculate the steady state voltage across the capacitor. Second thing, what is the initial voltage across the capacitor, and third thing, you have to calculate the time constant. Now in a RC circuit, time constant would be T equals to RC. Over here C is given, but R is basically not fetched directly, because here multiple resistance are there and they are connected in series or parallel. Over here two resistances are there and they are connected in parallel. So you have to calculate the R Thevenin. So time constant would be R Thevenin multiplied by capacitance. So three things we have to calculate: initial voltage, steady state voltage of capacitor and the time constant. Now further moving ahead, we will be seeing how the numerical can be initialized. So by the definition of step function, I told you that at time t less than 0, the magnitude of step function is 0, and for time t greater than 0, the magnitude of the step function is 30. So this is the definition of for the step function. So here is the main circuit and here is the two important circuits which are basically letting you know about the stages. For time t less than 0, if we talk about this circuit number A, okay, which is basically showing from figure A. So in this circuit, you know that at steady state, when switch is closed for a long time, at that time capacitor will behave as a open circuit. Okay, so that is why I just placed capacitor as a open circuit. Now likewise, when we talk about when switch is opened, once switch will be opened, this particular section will be disconnected. This 10 volt is disconnected. So over here you just see in figure number B, 10 volt battery is not there. Okay, and capacitor will be started charging with the help of 30 volts now. So it means the final value, the steady state value of capacitor, you have to determine with respect to 30 volts. So in figure A and in figure B, we can easily calculate the initial voltage and steady state voltage. So for figure A, for time t less than 0, switch is closed. Okay, When switch is closed for a long time, it is easy to say that V equals to 10 volt. Okay, because the capacitor terminal, the voltage across the capacitor terminal is parallel to the 10 volt battery. Okay, so capacitor voltage is 10 volt, and likewise you can easily calculate the current. You just draw the figure and try to correlate these expression, so you are able to calculate the capacitor voltage and capacitor current. So initial voltage you are able to calculate. Likewise, for time t is greater than 0, when capacitor will get charged by the 30 volt battery, thereby by applying the voltage divider rule, you can obtain the value of V infinity, but that is the steady state voltage. So over here voltage divider rule has been incorporated. Try to analyze from the figure B, thereby you can calculate the steady state voltage of the capacitor. Likewise, third important thing, you have to calculate the Thevenin resistance. So I told you in this particular circuit 10 ohm resistance and 20 ohm resistance are in parallel. So by that R Thevenin you can calculate. So I have calculated the R Thevenin, that is 20 by 3 ohm. Likewise, time constant, I told you time constant, how we can calculate? Simply time constant is what? RC. So over here we are talking about R Thevenin, so R Thevenin multiplied by capacitance, so you will get the time constant, that is 5 by 3 seconds. Okay, so you can pause down the videos, try to analyze V initial voltage, V final voltage, and the time constant. Once you are able to calculate and get the right answers, then we can move further. Now in the another expression, whereby if we talk about the figure number B, okay, in figure number B we have to calculate the voltage across capacitor. So this is basically the diagram of figure B. Okay, over here you have to calculate the voltage V. Now how we are able to calculate the voltage V? We will just take that expression which I told you, the main expression of voltage across the capacitor. The main expression was basically Vt equals to V infinite, that is steady state response, plus transient response, and we will incorporate all the values whatever we have calculated in the initial stages. So by putting those values you will get the answer like this. Okay, so this is the capacitor voltage. Now one thing very important in this particular capacitor voltage, that capacitor voltage waveform is continuous, because once you just put the value t equals to 0 over here, the waveform will certainly not switch instantaneously, it will be in a continuous mode. Okay, from t less than 0 to t equals to 0 and t greater than 0. But once we talk about the current, okay, current through resistor branches, thereby you can come to the conclusion that resistor currents would be discontinuous. Okay, now how we will calculate the resistor currents over here? So to obtain the current, we should take care of one crucial thing, that is what? Over here you just see, so this I current will be splitted to I1 current plus I2 current. So I current is splitted into I1 plus I2, and I1 would be what? V by 20, and I2 would be what? C dV by dt, and by this you can easily calculate the value of I. For this current is basically at time t greater than 0. So this is all about the RC circuit analysis, and if you want any such concept regarding any other circuit whereby number of storing elements are 2 or 3, try to comment or mail me that particular circuit on my email ID classgoeducation@gmail.com. So thanks for watching, thanks for your patience. If you want more such videos, kindly subscribe, do like and comment. Thanks for all your support and motivation. Have a good day.